Hi class, this is number 3 and 6.2. In her MAT 103 class, Professor Ayeb, okay, sorry if I botched that name, found that the mean score of the first exam was 87. Suppose that the scores are normally distributed with a standard deviation of 6 points. What is the probability that a randomly selected score is less than 49? And this is the notation that we would use to show the P stands for probability, and then they put in parentheses the probability of what the event they're interested in. So the probability of the event that our value is less than 49, this X variable is a score. I'm representing a score. A score is less than 49. That is just saying, eventually, hopefully, they want you to be able to just look at this notation and know that what they're asking for. So they're using that. All right, so all we have to do, hopefully you guys have been picking up on the fact that the probability of an event happening is just the area under, if these things are normally distributed, which they say they are, then it's just the area under the curve over that interval. So just like we didn't learn that a lot with the uniform distribution, it was just the area under the curve under that interval. And it was actually easy for us to find that area because it was a rectangle, and rectangles are easy. It's just the area base times the height. Here, let me just draw the picture, but the normal curve is actually a very complicated curve. We're not going to be able to, we don't have like a pretty formula to find the area underneath it, but we just use technology to help us actually calculate areas. But we do need to tell them the interval over which we want it to find the area of. That will be very important. And the mean and the standard deviation, because the mean and standard deviation determine the shape and height of this graph. And without that, they're not going to be able to find the area under the curve. So what is the probability that a randomly selected score is less than 49? So to even draw where the 49 is, I need to know where the mean is. So the mean is at 87. So that means at the peak of this hill, it's 87. Standard deviation is 6. So that means with, at halfway down this hill, I can take away one standard deviation would be 81. So and the reason why I'm drawing this on the picture is now I know where this 49 might be located. So I can kind of draw a picture. First, I'm going to draw a picture so you guys understand what it is that we were calculating. And then I'm going to actually use the calculator to calculate it. But now, because I know where the mean is the 49 somewhere over here in this region? Or is it somewhere over here in this region? And is it real close right here, or is it further over here? And so hopefully, I'll let you think about that for a second. Hopefully you recognize that this is a regular normal number line. So like when we move further to the right, we're getting to larger numbers here. So as we move farther to the left, you get to smaller numbers. So 49 is less than 87, and it's a lot less. A lot less. So I'm thinking it's like maybe way over here. Now, and the normal curve it's always like getting closer and closer to the x-axis. It's called the asymptote, but it never actually hits the x-axis. So there's always a little bit of, so what we're looking at, now we have to shade the region less than 49. So this is 49. Where are the numbers that are less than 49? Well, they're right here, right, to the left. So the area under the curve, which would be the probability that somebody would have the characteristic of having a test score of 49 or lower, would be this blue region right here that I'm technically it goes on forever, but it's basically at some point it gets so small that we're just like, let's just round it. It's 0 after some point. So this is the area that we're trying to find. It's kind of really important to draw this picture. You understand what the area is that we are trying to find. Once you draw the picture, then it's easier for you to see and describe to the calculator what area you need it to find what region you need it to find the area of, if that makes sense. Okay, because if you can't describe it, we can't just put 49 there. They're going to say, you mean all the numbers bigger than 49? Do you mean all the numbers smaller than 49? What the heck do you mean by 49, right? So we need to be very good with our interval notation. That's the reason for the discussion that I sent out about intervals, because we have to know how to describe an interval. So, and if we look at this, I always describe an interval as I go to the farthest place. I start off going to the farthest to the left, and I ask myself, like, I'm trying to like catch this shaded region, and I've reached far to the left, far to the right, and can I catch all of the blue region between my hands, you know? And then the left cutoff, where it goes from being shaded to not being shaded, that is my, left cutoff number. And then where it stops shading on the other side, that's my other cutoff number, okay? So this is a little bit tricky, because so I think you start thinking about it, where does this shading start? I'm looking out at the left side, asking myself, where does the shading start? And that's kind of a tricky question, because the shading is going on and on and on and on and on and on in this area. Remember how I explained to you that, like, the graph it looks like there's nothing there, but it's a little bit, tiny bit height. There's a little tiny bit of height to it, okay, as it goes out in that direction. So the best way that we can describe this interval is by saying it goes from negative infinity, because that's what's happening, because this is 49, the numbers are getting smaller in that direction, right? So 40, 30, 20, and eventually we'll go to negative numbers, 20, 10, 0, negative 10. And so the cutoff on this side is negative infinity. And we always use a curve bracket by that way. Then on this side, where does this now, so if I read it from left to right, and I tell where the shading starts, and I mention where the shading ends. The shading is ending right at the 49 there, and it's including 49. It's not, so I use a square bracket here. That's not so important, but just as we're talking about notation wise. This is important because if you're using a TI-84 calculator, this is your lower bound. The smaller of those two numbers is always your lower bound. And then this is your upper bound that they ask you for when you enter the calculator. Okay, one thing about the TI-84 calculator is, though, that it will not accept, it doesn't even have a way for you to input negative infinity. So you kind of sort of have to trick it into putting in, you have to have a workaround for that. So normally we put a really, really large negative number, like you can put you could probably get away with like negative 10,000 or something, or 100, negative 100,000. The typical number that people like to use, just so that they get a very accurate answer, is they use -1 e to the 99. And that means -1 times 10 to the 99th power. So that's -1 with 99 zeros after it. So that's an extremely large number. So this is going to be a very accurate answer, because if you put just -1,000 or something, it's just not going to be that accurate, and you want your accuracy to be high. So that's if you're using a TI-84 calculator. Make sure to not use -infinity, but use -e99. Now, also what I was going to mention too, if you're using a TI-80 calculator, I wanted to mention the mistake that students make is they use the subtraction symbol to put a negative sign in their calculator. And actually that's not the right way, and they're just going to mess it up for you. But there's a 3 symbol, and then right below the 3, there's actually a negative sign. And that's the symbol that you want to use whenever you're putting negatives into the calculator, as far as if we were doing our calculations for this, okay? That's the symbol on the calculator that you want to use, right underneath the 3. All right. So if you're using, and the way you would do that, I think the full process would be on a TI-84 calculator would be, you go to like stats, you know your second vars, distributions, then you go down to normal distribution, and you have to choose CDF, normal CDF, because over a range or interval, not just a single number. And yeah, normal CDF, and then you would enter this one, -e99 as your lower bound, upper bound 49, and then enter the mean 87 and the standard deviation 6, and then you would have your answer for the part A. Okay, let me show you, and we'll actually calculate the answer with the class calculator. So what you could always do is just open a new tab on your, I just like click a plus sign up here, and I put in this website, classcalc.com/graphing/calculator, and I just press enter, and in the calculator it comes up. So anyways, that's a great way to do it. But so if you're using the TI-80 calculator and you're trying to find that area under the curve, then you go to stats, you go to distplot, and then you go to normal dist, the normal distribution. And I love this program because it tells you what, see, it has a blinking, hey, I'm waiting for you to input something. It tells you what it's waiting for. And if you didn't know what those symbols are, it even goes into more depth. Hey, I'm looking for you to put in the mean, the population, and the standard deviation of the population. So it's looking for us to put in the 87 and the 6. And we're going to choose CDF because this is over an interval and not just, they don't want the probability of a one number. I don't really know the use of the PDF because we talked about earlier, the probability of exactly hitting one number would be 0 all the time. So I don't, maybe like 0, they probably really mean like one number to the next number, like from 3 to 4, maybe that's what they mean. Anyways, I've never used the PDF. Okay, so the cool thing is, well, they already have, this is where they want you to put the lower bound, and this is where you don't want to put the upper bound. So notice how they have the negative infinity and positive infinity already in there, and the class calc likes infinities, and so it accepts infinities, which is nice, but I don't know how to input it. Oh, there it is right there. So you probably would have to somehow press I don't know exactly how you would get to that. You might have to press and hold to get to that infinity. But anyways, if I were you, I would just like X out of it. They always already have negative infinity and positive infinity in there for you. So in this case, all I have to change is this side and put 49. And there's my answer. And it tells me it's 1 times 10 to the negative 10th power. So that means it's 1, but then I have to move the decimal place 10 times to the left. So it's point with 9 zeros and then a 1. So if we're going to be rounding that to any 2 decimal places or 3 decimal places or 4 decimal places or 5 decimal places, it's going to be 0. So our first answer here is 0. You have to be very careful when you are on a TI-84 calculator, because sometimes, and a lot of these times, we're going to be dealing with really small numbers here. So sometimes you're going to see your calculator say 3.75823, and it'll say e to the negative 4. That means this number, 3.75823, times 10 to the negative 4. So that means you have to move the decimal place to the left 4 times to get the actual answer. Okay, so don't want to make that mistake either on the TI-84. This calculator, I actually even like it even better, because they clearly explain this to us. It's 1 times 10 to the negative 10. Okay, and hopefully, you know, when you move 10 to the negative 10 spots, that means you're going to move the decimal place in the negative direction 10 times. So in other words, the answer here is 0 for this first part. So that's why we have an answer of 0 there. Okay. The next part says, what is the probability that a randomly selected score is more than 100? So now our duty is to first draw. See, I don't know the lower bound and upper bound. I'm not going to understand those unless I take time to draw the picture out. And another thing about drawing the picture out is that you can get an educated guess immediately at the answer. All of the area under the curve is 1. So right away, when I saw that this 49 was so far away from the mean, and that, like I was telling you, I was like, oh, it's so short over here. You know, it's barely any tall at all. Like, I knew this was going to be a small number. You know, because look at how small that area is, and look at all the white area that's left. You know, so that it's always drawing the picture is a great double check of your answer. Plus, it, like I said, and then plus it helps you draw the interval correctly. Okay, so let's see this one. So notice it says, what is the probability that a random score is more than 100? So we need to shade to find the probability is the area under the curve over that region where the numbers are more than 100. So I have to give myself a little bit of an idea where the 100 is located. That would be great. That way I can give my educated guess of what the answer is. So if I add 6 to 7 here, it'd be 92. So right here at this halfway down the hill is 92. If I add another one, that is that would be 99. So that's 2 standard deviations. So it's very close to 2 standard deviations above the mean. So you can already kind of see that, from the empirical rule, you can probably, if we just rounded it to 2 standard deviations above the mean, you could probably give a good guess using the empirical rule what this answer actually is going to be. But they say, what is the probability of the score being greater than 100? So where are the scores on the number line greater than 100? Well, they're getting bigger as we move to the right. So 100 would be like a little bit above this the second standard deviation above. So it would be like right here. This is the area we want to shade. I didn't draw it very good because it looks like it's tailing up, but it should be approaching the x-axis, right? Should be kind of more going like this, right? This looks like this area is probably going to be a little bit bigger than the other area, but not by much. It's still like in the tail. So probably with it being at more than 100. Okay. Now that I was like 100%, or that maybe this is not percentages of the test. Maybe this is just points they received in the test. But anyways, okay. So now let's carefully write down this interval. And I go from left to right and I ask myself, well, where does the shading start? And I didn't write it down here, but it's starting right at 100. So then actually is equal to 100. So I use a square bracket, not a parenthesis. But that's not too important for us, just so that we stay accurate with that it's not of no use to us in statistics. Okay, then it's tailing off and it keeps going, and like I can make more room, and I keep going and keep going and keep going and keep going. So where are we going to say that it stops? Where does the shading stop? Did you say positive infinity? And always positive infinity. We never really can say that we actually hit or include positive infinity. So we always use a parenthesis when we're drawing that. So if you're using a TI-84 calculator to get this problem right, you have to input this for your lower bound. And you always know, if you do double checking your interval notation, make sure your smaller number is always to the left and your larger number is to the right here in parentheses, okay, or square brackets. And this is our upper bound. Are you going to use in positive infinity for your upper bound in the TI-84 calculator? Not with the TI-84 calculator, you won't. You're going to have to, what are we going to use? You would use 1 plus 1 EE. And you don't use the E. There's a special EE on the calculator, and I can't remember where it is right now. It's like I'm trying to think about it, but like you don't use just the letter E. There's a EE button on the calculator, and you might have to press like second to get to it. But 1 EE to the 99. Even though for whatever reason when you use it, it just is 1 E, but like I guess it's E for exponent or something. I don't know. Maybe that's why they call it EE on the calculator. Okay, so that's your lower bound, and upper bound would be positive 1 because it's positive infinity, right? All right, and then you would use a mean of 87 and your standard deviation of 6, and that would be, so it would look like this into the input into your normal CDF. Where's the CDF? Okay. And then you would put your lower bound 100, your upper bound 1E99, and then your mean 87 and your standard deviation 6. Press enter and you have your answer for part B. Now let's see how you do it on using ClassCalc. But I still have the same mean and standard deviation. That makes these problems pretty easy. Okay, so then I exit out of that. And now instead, this is where my lower bound needs to be on this side and my upper bound on that side. So my lower bound is the number this time, the 100. my upper bound, oh, look, it automatically just put 1,000 in front of me. As soon as I took the number out, it just automatically put 1,000, and that's exactly what I wanted it to do. So our answer is 0.015, which they may round to 0.02. So let's see what they say. Oops. Oh, they just kept all 4 decimal places, 0.0151. And there you go. That's the answer, yeah. 0.0151. So they wanted 4 decimal places there. And there you go. That's the answer to that. There's only one last question here, and this is an even easier one. What is the probability that a randomly selected score is between 49 and 100? So let's draw the picture with that one. And I know I'm trying, it's like, oh, you have to draw it. Why do we have to draw the picture? And see, these are all fail safes to make sure that you don't make mistakes when you're on the test and you understand the content more. And it just, like I said, you're going to draw these intervals. You're going to double check your answers. And so I really recommend doing your pictures. Okay, and so we know 49 was way over here, probably even further than that. I'll just draw it there. And that 100 was over here. What is the probability that a random score selected is between those two? So the area that we're looking for is all of this area. Is this going to be, remember, all the area under the curve is one whole. So if you were to give an educated guess of what this area is going to be, what would you say? Focusing on doing interval notation, I have to just remember the first thing I have to do is to find this area is I have to describe the interval over which it's shaded. So where does this shade? I always do from left to right, like I read a paper, like I read, like we read. And I ask, where does this shading start? It starts at the 49, so that's my lower bound. And then where does the shading stop? It stops at the 100, so that's my upper bound. This is the easiest one. It doesn't have anything complicated like 1,000 or like infinity in any way. This is the easiest one by far. So that's my lower bound. This is my upper bound. So if you're doing your TI-84, it's normal CDF. Upper bound 49, lower bound 100, mean 87, and standard deviation 6. Press enter, you have your answer. Let's do using class calculator. Just to remind us how we got started that with class calculator, you can go to the website CLASS, or just type into your URL address calc/graphing-calculator and press enter, and it'll just come right up for you. You don't have to sign up for anything. You don't have to log in. You don't have to do anything. Click stat. Then I click on distance plots and normal distribution. Then I enter the mean of the data, which was 87, and the standard deviation was 6. Then I click on CDF, which that's the only one we're ever to note. The lower bound from our data, from what we just had described the interval, which is 49, and the upper bound was 100. And so that gives us our number, 0.98. And if I, knowing that all of the area under the curve was one whole, they say I'm not doing a very good job of drawing it, I don't think, because this is really tapering off. And you do a better job when you actually find out where, this is when you find out 3 standard deviations are below the mean, and so I can draw kind of more accurate picture of it. Usually I just draw in 1 standard deviation, and that kind of gives me a pretty accurate picture of what it looks like. Anyways, that is my answer. The probability that a score will be between 49 and 100 is 0.98. So very likely. That means that, so also if you want to understand that in a more concrete way, the probability is 0.98. What does that mean to me, right? Usually you can just truncate the number to 2 numbers, 0.98. Then you make the I into a lowercase I by putting a line under it, and then you put a line through that, and then every number in the numerator that's after the that was originally after the decimal, you put a number below it. You put a zero below it, and that means you turned it into a fraction. So that's equal to 9. That 0.98 is equal to 98 over 100. So that means that 98 out of every 100 times, 98 out of 100 times, you're going to get a score between 49 and 100. So it's very likely that you will. And you would say, I'm not surprised that I got a score between 49 and 100, right? All right, let's just double check our answer, and then we'll be done. There it is, 0.98. Oh, and they wanted us to be accurate to us, so I apologize. All right, well, email me if you guys have any questions, and have a great day, everyone. Bye.